started. I think hopefully most people are here. So I guess the layout of the test, it's 62 questions. 2 of the questions are extra bonus points. So essentially you could get 104% on the test, a little higher, 105% on the test. Just because sometimes there are discrepancies with how things are worded, students don't understand exactly what she's asking. So it's nice that she does that. She gives us 2 extra questions just to kind of give it at that. But because of that, she doesn't really let you argue points back and things like that. Well, honestly, the questions are super straightforward. I've been through the test, and so she sent me the copy of it, and I just went through it all, and they're all pretty straightforward. Any questions on the layout of the test, how that goes?
Is it all multiple choice?
All multiple choice, yeah. I would say most people took about an hour on the test. Some took about 30 minutes, some took a little longer. It's pretty much like if you know it, you know the answer, it's 5 seconds, you know? So it doesn't take a whole lot of time. Any other questions with layout? Okay, so today during the review, my goal is to just go through everything that will be on the test. I'm not gonna like say the questions that will be on the test, but I'll go through all of the content on the test, just so that there's no surprises. And so the test reviews are really important to come to. They help a lot. So at the beginning of class, we started talking about the body. We started talking about it in like the smallest units up to the largest. So she started out with subatomic particles. And then that went to atoms, to molecules, to macromolecules, and then cells, to tissues, organs, and then to systems. So in our body, all of these things are in our body. And so subatomic particles make up the atoms, which make up molecules, which make up macromolecules, cells to tissues, kind of goes in that order. And so specifically the things that she touched on were, first off, the macromolecules. She talked about 4 important macromolecules in the body. A macromolecule is essentially a polymer, and so anything that has multiple molecules put together. So some macromolecules that she had listed were carbs, lipids, proteins, and nucleic acids. So is, let's see, glycogen, what would that be considered? A carb, so macromolecule. So things like that, look for that on the test. Understanding that these make up macromolecules will be good enough. So, so moving on to cells. Cells are the smallest unit that we have in our body that can function towards a purpose. And so, as we have cells, those make up our tissues. And in our tissues, we talk about 4 primary tissues. Does anyone know what those are, the primary tissues? Nerves.
Epithelial.
Connective. Epithelial. So I was taught the acronym CMIN. And so connective tissue, muscles, epithelial, nerves. Those are the 4 types of connective tissue. Those are the 4 types of tissues. So connective tissue, I did it takes too long. What are some examples of connective tissues? Blood is a connective tissue. What else? Bones, connective tissue. Tendons, ligaments. That can be classified as fibroblasts, anything that's making up the fibrous parts of our bodies. So for connective, we have the bones, blood, and fibroblasts. Muscles generate the movement in our body. And are muscles voluntary or involuntary? Both. Make sure you remember that. We have our skeletal muscles that are voluntary. We control that. We decide what our muscles are going to do. And then our innards, our organs, the vessels, those are involuntary muscles. And so that's something to remember. And then we have the epithelial and nervous tissues. So this is the makeup of the body. This is how everything is made up. And in our body, we want to maintain our environment, homeostasis. Who has, I guess I gave a definition. Homeostasis is maintaining our internal environment. And so with homeostasis, we talked about two things, two ways that our body regulates that. What were those two ways? Negative feedback and positive feedback. Alright, so what is negative feedback?
It's like when you do the opposite of whatever your body's doing.
Okay, so what's perfect. What's an actual example of negative?
Hot, so you sweat.
Sweat. When you get hot, you sweat. What else?
You shiver when you're cold.
Like if your heart rate rises, your blood vessels are going to dilate or something to lower that. Is it dilate or is it open?
There's both. So if your heart rate rises,
You want it to close.
your blood vessels will open up a little bit,
Okay.
so it's less pressure going through. So those are negative feedback. So we just kind of gone over this essentially all we've gone over. That's really good. Negative feedback, like she said, was just taking, if our body's going away from homeostasis, it's going to turn the system around and cause it to come back to homeostasis. The other one was positive feedback. So what are some examples? I guess, what is positive feedback first off? So it continues in the same direction. So that is a lot less common. What are some examples of positive feedback in our body?
Clotting.
Clotting, how so?
Good question.
Okay, we'll go over that a lot more in detail. But I guess just when we have a cut, our body's going to want to stop it from bleeding. So it's going to continually send those clotting factors to it. Positive feedback. Another one she talked about was ovulation. So with females, as their hormones are causing the ovulation to start happening, it's going to continually send those hormones until the egg comes out. So with positive feedback, it's going to continue doing that until something shuts it off. So those are examples of negative and positive feedback. Any questions of any of this we've gone over?
Is during birth, contractions in the cervix and stuff, is that an example of positive feedback? Because as
Yeah, I would think so.
contraction, because the cervix keeps contracting
Yeah.
and then it keeps receiving if
Yeah.
activity comes out.
I think that's a good example.
Can you give those examples of negative feedback again?
Yeah, so there's a ton. We have blood pressure is a good example of negative feedback. Temperature in the body, like we talked about with sweating, shivering, different things like that. Our blood vessels constricting or dilating to diffuse temperature throughout our body. There's a ton. Essentially, understanding that this is our body's going away from homeostasis, and negative feedback is bringing it back, and positive feedback is something is moving in a direction, and then it's continually pushed in that direction. Does that make sense? Okay, was there another hand question? Okay, perfect. So that's that with the intro stuff that we started with. Then we went into some chemistry. I'll leave that up for you. With chemistry, we had a few equations. Who knows the equation to solve the pH when you're given the hydrogen ion concentration?
Lot of 1 over concentration.
So we have pH is equal to log of 1 over your hydrogen ion concentration.
Are we gonna need to memorize this?
So memorize the equations. That's something that you're going to need to know, each equation. So practice problem. If our hydrogen ion concentration is equal to 10 to the negative 7, what is it going to be our pH? Everyone take some time to do that, and then talk about the answer here in a second. Everyone good? Any more time? Okay. So, what is the pH? 7. You can go ahead and put it into this whole thing, or you can just take that number. And that's that. So, if hydrogen ion concentration was 10 to the negative 3, pH of 3. Hydrogen ion concentration 10 to the negative 13, pH of 13. So what is the hydrogen ion concentration when we have a pH of 6?
Negative 6.
10 to the negative 6. Pretty easy. The equations in this class are very straightforward. Okay. Then the next equation that we got in this unit was the Henderson-Hasselbalch equation, which deals with finding the pH when we have bases and acids in those concentrations. Who knows the equation for that?
pH equals pKa plus log of base over acid.
Yeah. Okay, perfect. So that's an equation you'll need to memorize. Make sure to get that down. So let's do a practice problem with this as well. So in our bicarbonate buffer system, I'll just go ahead and write that up here. Does everyone know that? Who could say that out for us?
6.1.
Well, yeah, the pK is 6.1. But in the bicarbonate buffer system, let's just write that buffer equation out. Yeah, so we got CO2 plus H2O.
Should we memorize that?
Yeah. H2CO3 goes to HCO3 minus plus H plus. This is a bicarbonate buffer system. We'll use this a lot later on. But for a practice problem, if we have a concentration of 36, so our bicarb concentration is 36 molar, and our carbonic acid concentration is 1.2 molar, 1.2 millimolar, sorry. What would be the pH? Everyone take some time to figure that out. Does everyone have that? What pH did people come up with?
6.
Okay, 10.6. Everyone get that? Anyone need us to walk through it? Yeah? Okay. So, base is associated with the bicarb. Acids associated with the carbonic acid. Does everyone kind of see how that is? When you have, so looking at this, dissociating, we have our acid, it's going to dissociate, lose the hydrogen ion, and just become, what's that called? Conjugate base, yeah. So we're going to go ahead and we're going to put the 36 molar up here for the base, conjugate acid. And then for the carbonic acid, we'd put that down here, but because it's millimolar, we need to change the values so that they're equal. You can do whatever you want. You can change this to millimolars or change this to molar. I went ahead and just changed the carbonic acid to molar, so that would just be 0.0012 molar. So you just need to remember to get them in the same units, and then it's just a matter of plugging it into the calculator. Divide that through the log of whatever you get, and then add it to 6.1. Any other questions with that? Should we do another, or is everyone feeling good?
Can we do one more? Unless people are like,
Sure, yeah,
Okay.
we can do another. Okay, so if, I'll just make these up. 3 more molar and 3 more. So what is the pH?
Just on the test, we're always going to assume when we see a problem like this that it's the bicarbonate buffer, not the phosphate buffer, right?
Yeah, she'll tell you.
Okay.
But yeah, on this test, just focus on the bicarb. But in all the questions, she'll tell you what she's wanting to focus on. Okay, we ready with this one? Okay, what is the pH we got here? 3.1. Feeling a little better about that? Good. Perfect. So this is the other equation that we got. And so those are the 2 equations that you're going to need to memorize, as well as this buffer system. So what is a buffer? Neutralizes base or acid is what was set up here. A buffer is anything that resists pH change. And so our body wants to stay at a constant pH. We have buffers in our body to make sure that the pH range doesn't change, or else we're going to have problems. So this equation is in equilibrium. What does that mean? Balanced. Does that mean we have the same amount of CO2 and H2O as we have here? How come? What is that? What do we have the same of? If it's in equilibrium, what do we have the same of?
hydrogen.
An equal flow back into
Equal flow. So equilibrium is saying the rate of the reactions this way is equal to the rate of reactions this way. So it's not saying we have the same CO2 and H2O concentration as we have these two. It's just saying the rate, the flow, is the same. So what's going to happen if we increase CO2? What way is the reaction going to go towards?
Right.
To the right. Does that make sense? So if we increase CO2, it's going to go to the right. What happens if we decrease CO2?
To the left.
To the left, yeah. Same thing, increase bicarb would go which way? Left. Decrease bicarbonate would go to the right. Any questions?
Are we always going to write the equation that way so that if there's a question that's like, say, is the equation going to go to the right or the left, it's going to be like that?
Good question. Yeah, just make sure to always write it this way. Start with CO2 in each tool. So with this in the assignment, there are a lot of really good questions about how is our body going to react when certain things take place. There is on the test one situation like that. On my test there were a few more than that, but this time she just did one situation. So with the bicarbonate buffer system, there's things that can happen in our body, alkalosis or acidosis. But there's two types of each of those. So we have respiratory and metabolic. And then this goes into acidosis and alkalosis. And then same down here. So what is an example of respiratory acidosis? What would be happening? Yeah, so breathing slowly, holding your breath, hypoventilating. So when we're hypoventilating, breathing slowly, holding our breath, CO2 is going to go down. Wait, respiratory acidosis. Okay, so if CO2 is going up, my bad. So CO2 will be going up, which how does that affect the acid in the body? What else is happening?
Acid goes down.
H plus goes up, so the acid, the pH is going to go down. So the way this is happening, CO2 is going up, that's going to push the equation to the right, creating more of this. Acid's going to go up. So if acid's going up, pH is going down, more acidic. So respiratory deals with our lungs, the breathing. Respiratory deals directly with the CO2. So opposite situation would be respiratory alkalosis. CO2 is going down. We're hyperventilating, breathing really rapidly, getting a lot of oxygen in our body and expelling all of our CO2. As such, hydrogen ion concentration will go down because the equation is going to the left. Does that make sense? So what is metabolic acidosis and alkalosis? First off, metabolic acidosis,
Vomiting.
vomiting. So metabolic, just think respiratory is anything dealing with our lungs. Metabolic is everything else. So if it's with our lungs, remember it's respiratory. Anything else is metabolic. So you said metabolic acidosis. So if we're vomiting, what's happening? So we're eliminating H+, so H+ is going down. So pH would go which direction? Up. So that would be metabolic alkalosis. Because acidosis is associated with pH going down. Alkalosis is pH going up.
Well, acidosis would be like diarrhea. Is that the opposite? Yeah. Okay. That
Yeah,
makes
so
sense.
Alkalosis, we're losing bicarb, so our H+ will be going up. That's going to be alkalosis, yes.
Can you give like more examples of each of them? The acidosis, like is that vomiting or what are more
Okay,
examples?
yeah, so acidosis, we could have vomiting. Sorry, that's alkalosis. Okay, acidosis, we'll start there, sorry about the So severe diarrhea would be acidosis because we're getting rid of bicarb. So our acid is going to be going up. There's going to be less bicarb to push the equation this way. So that would be your acid. Sorry, I'm confusing myself. bicarb. So that's going to push the equation this way. And so that, yeah.
Wait, wouldn't it push?
Doesn't that push the equation to the left?
It does. Sorry, let me look at this real quick.
CO3 goes down. Sorry, Dr.
So acidosis is when the pH is going down, meaning H plus concentration will be going up. So,
The CO2 will go up.
mhm,
So that would also.
yeah. One second. let me look at something. So severe diarrhea, does that make sense that it's
Loss of
alkalosis?
bicarb.
It's acidosis.
Is it
It's on the PowerPoint, it says
Yeah.
metabolic acidosis, severe diarrhea, loss of bicarbonate. That's what she
For
said.
some reason I'm confusing myself with that. Because if bicarb we're losing that with diarrhea.
So the
Does
equation
it CO2 go up?
Oh yeah, equations go to the right. There we go. My bad. See, you're all gonna ace the test, you know this stuff better than me. Okay,
That's acid.
so that's acidosis because if H plus is going up, pH is going down. Diarrhea.
Basically, anytime it's acidosis, you're gonna increase H plus.
Yes.
But if we're vomiting, we're losing acid,
Mhm.
so,
That would be alkalosis.
okay, yeah, I thought diarrhea and vomiting were the same.
So that would,
Well, yeah, you know.
it's confusing. Just take time, it helps to write this out, helps a lot.
So in both of those equations for diarrhea or vomiting, the equation would both move to the right, right?
So, yes. Okay,
One is
so
alkalosis, one is
diarrhea,
acidosis.
diarrhea, we're losing bicarb. Nothing is happening to the H plus concentration. So the equation is going to shift to the right. So even our H plus concentration is normal before it shifts, but because it's going to shift, H plus is going to go up. So that is going to decrease pH acidosis. So vomiting, our pH goes down. That's just straight that way. pH or H plus goes down, pH goes up. Alkalosis. That makes sense. Sorry to confuse you all. Confuse myself too.
Super.
Okay, so if you're experiencing acidosis, your breathing is going to what? Increase?
So if we're experiencing acidosis, that means H plus levels are what?
Are high.
Acidosis?
No, they're low.
Acidosis. Oh, they're
Acidosis, H plus levels are
high.
high. H plus levels are high, so pH is low.
Oh, pH is.
So if that's high, CO2 also has to be high.
Okay, so then we're going to breathe, we're going to increase our breathing.
Decrease breathing. So think about holding your breath. Your body's still doing all of its reactions inside. It's creating CO2. If we're holding our breath, we're not getting rid of the CO2.
Okay,
So if we're holding our breath, CO2 is going to go up.
but I thought with acidosis that your CO2 is too high. So don't you want to breathe more?
The H plus is.
Yeah, with acidosis, H plus is high.
Oh.
Yeah, so if H plus is high, it's going to shift to the left, naturally creating more CO2. That's how the buffer system works.
Okay.
Does that make sense?
Yeah.
Okay. Any other?
To counteract, you'd want to hyperventilate.
Yeah.
Okay. I'm
Any other questions with this? Sorry to confuse you. Okay. So that's what you need to know with this. Respiratory acidosis and alkalosis, metabolic acidosis and alkalosis. Another thing we touched on with chemistry was hydrophobic and hydrophilic. What is hydrophobic? Hydrophobic, phobia, fear. So hydrophobic, afraid of water. They don't like to be in water. Hydrophilic, likes to be in water. So what is lipophilic? It likes to be in lipids. Lipophilic associates with hydrophobic. They're opposites. Does that make sense? So hydrophobic goes with lipophilic. Hydrophilic goes with lipophobic. Does that make sense?
Okay, one more time?
I'll write that
One
down.
more time.
Hydrophobic equals lipophilic. And hydrophilic equals lipophobic. Yeah, so mixing fat and water, they won't mix. So essentially all you need to know that. Good? Okay. Then we go into cell structure. And with cell structure, we went over all of the different types of organelles in the cell. And so we've all gone over that, but we'll briefly go over it again. The nucleus, what is the importance of the nucleus?
DNA.
Well, it's the genetic material. So in the nucleus, we have a nucleolus. What takes place in the nucleolus? RNA synthesis takes place in the nucleolus. Okay. Yeah. So nucleus, genetic blueprint has our genetic information, and then also contains the nucleolus where RNA is synthesized. We have our cytoplasm, which is just the outer portion of the cell, outer portion of the nucleus. And the cytoplasm is, it just like holds all the organelles in place. That's mainly its function. Rough ER, what does the rough ER do? So the rough ER, what you need to know for this class, does a lot more than you need to know, but it's covered with ribosomes and essential for protein production. So it helps in the process of protein production and sending the proteins where they're going to go.
Can you say that one more time?
Yeah, so the rough ER is essential for protein production because it kind of helps the proteins navigate where they're supposed to go. Okay, then the smooth ER. Does anyone know what smooth ER does? Mm-hmm. Yeah, lipid synthesis is what the smooth ER does. Lipids and steroids. That's what the smooth ER helps with. Helps produce those. The Golgi Apparatus. What's the importance of the Golgi Apparatus? Essentially, it packages them up and ships them out of the cell or wherever they're supposed to go.
What is it packaged?
Yeah, so it packages them up and then ships them. It's essentially like a FedEx. So
The proteins.
yeah, the proteins.
Proteins.
Okay, yeah, sorry. Get your question now. So it packages the proteins and sends them out.
Is the cytosol the organelles and the cytoplasm?
Yes.
Couldn't remember.
Wait.
Cytoplasm is the cytosol and organelles.
Okay.
Opposite. Sorry about that. So cytoplasm is the cytosol and all organelles. Okay, so moving on, lysosomes and peroxisomes, what do they do?
Eat on the garbage.
They're digestive enzymes, get rid of the garbage in the cell.
Sorry, what are they called again?
Lysosomes and peroxisomes.
That's like the garbage bin.
Yep. What is the importance of ribosomes?
Protein synthesis.
So ribosomes aid in protein synthesis. We'll go over that in more detail in a little bit. The mitochondria. What happens in the mitochondria?
ATP.
ATP production. It's often called like the powerhouse of the cell. So mitochondria, ATP production. And then the cell membrane. What's the importance of the cell membrane?
It's a barrier protection.
Structure keeps everything in. So what is the cell membrane made of? Phospholipid bilayer. So is a phospholipid bilayer hydrophobic or hydrophilic?
Yes.
Oh.
Right. Both. So, but the lipids, something important to remember with cells, the lipids are lipophilic or hydrophobic. So with the cell, when things come into the cell, she briefly touched on this. So we have, I'll show a portion of it. Okay, so when something's coming into the cell, if it's hydrophobic, it's going to be able to pass straight through. The draw towards the lipophilic center is going to be able to pull that molecule straight through. If it's hydrophilic, you're going to need a protein that will allow it to pass through.
Hydrophobic?
If it's hydrophilic. So hydrophobic things can pass straight through a cell membrane. Hydrophilic things are going to need a protein carrier or a passageway. That's because hydrophobic things are drawn towards the lipids. Hydrophobic things attract each other, and so they can pass straight through. Something briefly that she talked about. Okay. Okay, so that is it for the organelles that we'll focus on. With the cells, there are certain junctions that we talked about in class. One of them, tight junction. What is a tight junction?
A zipper.
Yeah, so a tight junction, good way to think of it as a zipper, holds things together really tight. Are things able to pass through a tight junction? No.
Small molecules, right?
So not with a tight junction. With a tight junction, things are going to have to go through the cell itself. So where would we find a tight junction?
Or stick.
Not skin. Water can pass through our skin. There's a junction. Digestive system, because we're not going to want acids leaking out into our body different places. So digestive system is where we have tight junctions. The cells determine what comes in and out, not the junctions. Another junction we talked about was the desmosomes. So what are the desmosomes?
They hold the cell to the base membrane.
So the desmosomes, they hold the cells together that aren't like actually touching. It's kind of in between the cells and holds them in place. So things can pass through desmosomes. So where would we find desmosomes? Skin. Moisture comes through our skin really easily. Different things come out of our skin, hormones, things like that. And then another junction we talked about were gap junctions. Who can explain what a gap junction is? Essentially, tunnel between two cells. Things can pass through that junction. It's how cells communicate to one another. What is an example of a gap junction? Where are those found? The heart. Heart needs to be communicating all the time with each other, with the other cells. So gap junctions allow things to pass to and from each Cells, sometimes they eat other things. What is that called? Phagocytosis, which is a part of endocytosis, is like the overall word. So endocytosis is when the cells are going to engulf something and eat it. And then phagocytosis, like you said, is part of that when the cell just kind of engulfs it. But then there's also receptor-mediated endocytosis, and so that is when there is a protein or something on the cell that is a specific, it targets a specific molecule, and then it will eat it. So that one is called the receptor-mediated endocytosis. And that is endocytosis that just targets a specific molecule.
Are they like antibody resistance, like antibiotics?
Similar thing, but it's that the cell is like engulfing it and taking it in.
Yeah.
So, yeah, we'll go a lot more into the immune system when we get to that unit, but it's a similar concept. It's targeted for that specific molecule. Okay, pinocytosis, what is that?
Drinking water, like really small debris.
So pinocytosis, the way she explained that, was the cell drinking.